In sample setup part 2, we picked the spectrometers and we found the background positions that we wanted to use, and we also checked that if we wanted to set up any interference corrections. Now what we want to do is we want to calibrate our standards. So the last thing we ran was a wave scan, so to make things easier we'll do a new sample and set up an unknown. I'll just call this calibration, it doesn't really matter what you call it. We'll say OK. And we'll check the count times. 60 seconds on peak is probably a good value, but I'll slow this right down to make it easier for us to go through the demonstration. So 20, 10 and 10. So each calibrating point is going to take about a minute. Let's just check the anodes and cations. This carries over the setting we had from the previous sample. So we can check that we've got that peak position, high and low backgrounds. Now for the copper and the sulfur we set asymmetric backgrounds, so we can check that those are still set, and that is true. Those nickel and sulfur, so it has carried those over correctly. Now to actually set up the calibration, it's very easy. We go to standards, again select standards, and it selects the standards that we've got loaded for this analysis run. Again, like we did for the wave scans, we can confirm the standard positions, but I'll assume that we know that they are in the correct positions. What we want to do is we want to select acquire standard samples. What this will do is it will automatically move to each of the standards and run the calibration for you. Now at the moment we have 1 point selected for each of these standards. And down here you'll see that we've got standard points to acquire. We've set it to acquire 5 points, and with a standard X increment of 5 microns. So what the software will do, it'll move to the first position we've got stored, do the first calibration, then it'll move the stage in the X direction 5 microns, or whatever value we set here, acquire the second point, then increment again until it's done the 5 points that we've asked for. You could, if you've got a porous sample or one that has lots of cracks or features that you want to avoid, you can actually store 5 discrete points for that standard, and it'll use those stored points instead. You'll also notice there's a re-standard Y increment, and this is if you want to acquire standards again. Say for example you want to acquire them after you've completed your analysis run. You don't have to go and set a new point. You just acquire standards again, and it'll automatically go to your saved point and then increment in the y-axis direction 5 microns, and then increment in X for those 5 points. So it just makes it very easy to acquire. So we acquire the standard samples, we'll run the selected, asks us to confirm the number of positions we're doing, so 3 standard positions, no unknowns, no wave scans, and it's going to take about 33 minutes. So the first thing that it'll do is it'll set up the analysis conditions. So we've moved to the first standards, we see we've moved to the copper metal. Now one thing you'll notice is that it's actually acquiring all of the elements on all of the standards. This is different to the way you do it on the Kamika or jail software, where you'll only calibrate the element of interest on the standard that's relevant to that element. But we'll see when this is run why it's advantageous to acquire all of the elements. So we'll cut to when this is completed. We're just coming to the completion of the 5th and final point on the 3rd standard, the iron metal. Just wait for that to complete. And that's the automation completed. I'll close the automate window just now since we don't need it for the moment. What we'll do is we'll have a look at the analyze window. I'll move this over. We've got the standards selected, and we can see we've got points stored for our 3 standards. Now if you double click on any of them, so we double click on the copper metal, we can see that we've got the raw data for that standard, including the 5 analysis points. Now the benefit of doing all of the analyses, all of the elements on all of the standards, is we can actually run these as quant analyses. So we can click the Analyze button and get a quantification result out. Now this is copper metal, so we'd expect to see 100% copper and very little iron, nickel or sulfur. And within the noise limits, that's what we've got. We can double click on the nickel sulfide and we should have nickel and sulfur with no copper or iron. And on the iron metal, so we'll analyze that one. Again, pretty much 100% iron, no nickel, essentially no copper or sulfur. Now if you're using a standard that has elements which you haven't analysed for, so for example if we'd used an iron oxide instead of an iron metal, the software would have added the oxygen in from the standard composition value so that you would still be able to get a proper analysis total, and we would still be able to tell if we have good analysis total. Now if you investigate either the raw data or the analytical data and you see that one of the values is off, then that gives you an idea of there's a problem with one of the standards or one of the elements, and you can go back and look at your setup to check what the problem is. So one of the problems might be that you've got an interference correction that needs to be added in. Well, because we've acquired all of the data on all of the standards, we can actually go in and change the standard assignments, and we could actually check for an overlap correction. We can add that in, we can click OK, and we can re-quantify, and it'll use that standard correction. The other thing we can do is we can change what type of background we're using. We can't change the background positions obviously because we've acquired the data at those positions, but we could change it from a linear to an exponential, for example, or if we did have a problem with one of the backgrounds, the high or the low, we could use the good background and apply a slope value to recover that, rather than having to necessarily recalibrate. Now the other thing we can do is, for example, if we look at the nickel sulfide and we look at the calculation options, there's all sorts of options. So we can display it as atomic percent, so we'll see what that looks like, and as we'd expect we're getting 50% nickel, 50% sulfur. The other thing you can do is you can display them with stoichiometric oxygen. If they are oxides, you can display the results as oxides. Or, because we've got a nickel sulfide, we want to know what the atomic ratio is. We can calculate a formula based on, say, 1 atom of sulfur, and analyze again, and this now gives us the atom ratio. So indeed we've got 1 atom of sulfur and 1.008 atoms of nickel, so that's pretty good. So I'll turn that off just now. So that's how to calibrate your standards. In following videos we'll look at how to store positions and how to do some of the more clever things that probe software allows you to do.